Hello and welcome to all students. This is FY BCom class semester 2nd Mathematical and Statistical Techniques 2nd unit number 2 Derivatives and Applications. In this lecture we are going to study about price elasticity of demand. So let us we define what is meant by price elasticity of demand. Okay, so let us start. So here price elasticity of demand definition is, suppose we are given a demand function. So let us write here, suppose we are given a demand function. Suppose we are given a demand function which gives a relation between which gives a between relation between demand D and price P. Demand D and price P. Okay, then the price elasticity of demand eta is, then price elasticity of demand is given by is, then we write the formula for price elasticity of demand, and that formula is here eta. So notation for price elasticity of demand is eta is equal to minus P upon D into dd by dp. Okay, so you observe that this is the formula for price elasticity of demand. Okay, now we write here some observations. So observations are, so first observation is the price P and the demand D are always non-negative. So price P and demand D, they are always non-negative, means greater than or equal to 0. Now the second observation is demand is a decreasing function, therefore the as demand D is a decreasing function, therefore the derivative of the demand with respect to the price P is also always negative, it is always okay. Therefore we observe that the quantity on the right hand side of this formula, so this quantity is negative and this quantity is negative, so negative into negative is positive, therefore hence eta is equal to minus P upon D into dd by dp. This quantity is always non-negative. Okay, so this quantity is always always non-negative, is always non-negative, means eta is always greater than or equal to 0. That is, eta is always greater than or equal to 0. Okay, so this is the main observation. Okay, and we write some notes here. Our first note is if eta is equal to 0, demand D is constant and the demand is said to be perfect elastic. So right here, if eta is equal to 0, so this will implies D will be constant, and in this case demand is said to be perfectly elastic. Okay, now second note is, if our eta is greater than 0 and less than 1, then demand is said to be inelastic. Okay, then demand D is inelastic. Third observation is, if eta is equal to 1, then if eta is equal to 1, then demand is directly proportional to price. Then demand D is directly proportional to price P. This is the third observation. And what we have is fourth observation is, now if eta is strictly greater than 0, then demand is said to be elastic. D is elastic. Okay, so these are the 4 points to be noted here. Okay, so now let us go to the next point now, and our next point is the relation between the marginal revenue and the price elasticity of demand. So let us write here next point in this lecture: relation between the marginal revenue MR and eta. Okay, so we directly write the relation between marginal revenue and eta. So relation is, see here, marginal revenue is equal to average revenue into bracket 1 minus 1 upon eta. So this is the relation between marginal revenue and price elasticity of demand. So this is one relation. Okay, second, this is one equation which represents the relation between marginal revenue and eta. Now we have second, the marginal revenue is equal to, so average revenue is always equal to price, therefore it is marginal revenue is equal to price into 1 minus 1 upon eta. Okay, So these are the two important relations, or the this is basically it is only one relation, and it is important relation between marginal revenue and price elasticity of demand. So let us try to solve some examples based on this relation. Okay, let us write question number 1. Question is, if the demand function is given by, if we have given a demand function d is equal to 15 minus 4 into p minus p square. Okay, find the price elasticity of demand, comma, find price elasticity of demand means we have to find eta. Find eta when p is equal to 2. Okay, so let us write the answer of this question. Answer, so what we have given first, d is 15 minus 4p minus p square, and we have to find eta, when price p is equal to 2. Okay, but we know the formula for eta. So formula for eta is here, eta is equal to minus p upon d into d by dp. So first of all we find this derivative. Okay, let us call this equation star. Okay, star equation. So we will use this equation afterwards. So first of all we find the, here now we find the derivative of d with respect to p, and it is equal to derivative with respect to p of the demand function. That function is given to be 15 minus 4p minus p square. Okay, and it is equal to, so derivative of 15 is 0, minus derivative of minus 4p is minus 4, and minus derivative of p square is 2p with respect to p. Okay, and finally what we have is minus 4 minus 2p. So this is the value of this derivative. Okay, now eta is equal to, okay, now we find the eta. Now we write eta is equal to minus p upon d is given, and that d is 15 minus 4p minus p square into derivative is minus 4 minus 2p. Okay, so in the next step we write here, put p is equal to 2. We have to find this price elasticity of demand at p is equal to 2. Therefore eta is equal to minus 2 divided by 15 minus 4 into 2 minus 2 square into minus 4 minus 2 into 2. Okay, and it is equal to minus 2 divided by, so this is 15 minus 8 minus 4, so it is I think 3. Okay, so this is minus 8 minus 4 is 12, minus 12 and plus 15 is plus 3. Okay, into bracket, this is minus 4 minus 4 is minus 8. Okay, and final calculation is eta is equal to 16 upon 3. So this is price elasticity of demand, and its value is uh, okay, 5.33. okay, and here eta is greater than 1. Therefore our observation is, what is our observation is that demand mentioned in this question, the demand D is elastic. Okay, so this implies demand D is elastic. Okay, so our main question is here to that our main question was to find the price elasticity of demand. Okay, and that price elasticity of demand is 5.33. okay, so this is our extra part. Let us take next question based on this. Now let us take next question. We write the question number 2. okay, question 2 is, if MR, marginal revenue, is equal to 20 and elasticity of demand with respect to price is 2, and elasticity of demand with respect to price means we have given eta is equal to 2. okay, find the price, find price P. okay, so let us write the answer for this question. Answer. Okay, so we use the relation between marginal revenue and price elasticity of demand. Here we know that the relation between marginal revenue and elasticity of demand, that relation is MR is equal to P into bracket 1 minus 1 upon eta. So we put the values of MR, eta, so that you will get the value of price P. So MR is 20 is equal to, P is not given, we have to find that P. 1 minus 1 upon eta is given, eta is 2. okay, and in the next step it is 20 is equal to P, and this is 1 minus 1 half is 1 half. okay, and so finally we get 20 into 2 is equal to P. okay, therefore 20 into 2 is 40 and P is equal to 40. okay, therefore price P is equal to 40. okay, so this is the end of this question also. So there are many questions are given. I would like to give one homework to you. So homework based on price elasticity of demand. Let us write the question. Question is that if the demand function is given, D is equal to P plus 2 divided by P minus 1, comma, find the elasticity of demand, means we have to find the eta. okay, find the elasticity of demand when the price is 3. okay, so this is our first question. Now let us go to the question number 2. Second homework for you. Second is, okay. So next question is, what is given to you if if the demand function is given to you, d is equal to minus log of p, okay, demand function, then show that eta is equal to 1 upon d. So try to solve these two examples, okay. And this is the end of this lecture, and thank you for paying attention.